to projects. In this video, we are going to explain about the project, which is a machine learning based framework for a stage-wise classification of date palm white scale disease. Introduction of the project. The date palm holds immense socio-economic and ecological importance in Morocco, constituting a substantial portion of agricultural revenue, particularly in oasis regions. Recognizing its significance, Morocco's Green Plan prioritizes the cultivation of date palms, supporting farmers who contribute to over 60% of agricultural income and employ more than 2 million people. Precision farming in date palm cultivation faces challenges, notably in the detection and classification of plant diseases. Identifying diseases affecting date palms becomes crucial for farmers, especially when symptoms are similar, complicating the selection of appropriate treatments. The palm date scale, though considered a minor pest, can cause significant damage from affecting fruit quality to jeopardizing the tree's survival. Effective disease detection and classification play a pivotal role in precision farming strategies. Farmers encounter difficulties in accurately assessing the degree of infestation, particularly when symptoms overlap. The choice between chemical treatments and alternative practices is contingent upon the severity of the infestation, making regular visual inspections a time and labor intensive task for farmers and experts. The primary aim of the project is to assess the efficiency of machine learning methods in identifying and categorizing wide-scale disease within date palms. To achieve this, the project employs feature extraction techniques on multi-scale image dataset, generating descriptors such as gray level co-occurrence matrix, which is GLCM, and hue, saturation, and value, which is HSV color movements. These characteristics are then utilized to train classical and ensemble-based machine learning models. Contributions include exploring classical and ensemble based machine learning for WSD detection and infestation degree classification. The project assesses GLCM and HSV features and compares texture only versus combined color and texture patterns for accurate WSD recognition. The proposed solution aims to empower date palm growers with machine learning for precise disease identification and informed decision making. Objective of the project. The primary objective of the project is to develop a robust framework for early detection of wide-scale disease in the date palm trees, aiming to mitigate the economic and environmental impact of this damaging bug on oasis agriculture. The goal is to classify WSD infestation into four categories, which is healthy, stage 1, stage 2, stage 3, to guide farmers and deciding the necessity of chemical treatments for effective pest control. Utilizing feature extraction techniques, the project aims to investigate gray level co-occurrence matrix, which is GLCM, texture features, and hue saturation value, which is HSV, color movements, features from leaflet images. The focus is on employing machine learning algorithms for accurate classification based on these extracted features. The project involves testing two categories of machine learning algorithms, which are classical methods like support vector machine and k nearest neighbor, as well as ensemble learning methods such as random forest and light gradient boosting machine, which is light GBM. The objective is to identify the most effective algorithm for WSD classification. The ultimate goal of the project is to provide a practical and effective tool for the Oasis agricultural community by achieving accurate detection and classification of WSD stages. The proposed framework aims to enable early intervention, assisting farmers in adopting preventive measures to protect both date palm trees and crop yield. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. This step involves importing necessary Python libraries and packages that are required for the project. We imported NumPy and Pandas for data manipulation, Matplotlib for data visualization, sklearn for machine learning, TensorFlow for deep learning, and Flask for web development. Exploring the dataset. In this step, the dataset containing images of date palm leaves affected by wide-scale disease is explored. This includes understanding the structure of the dataset, checking for any missing or irrelevant data, and gaining insights into the distribution of classes. Image processing. This phase focuses on preparing the images for model training. Here we extract features using GLCM and HSP. GLCM refers to Gray Level Co-occurrence Matrix. It is a statistical method used in image processing to quantify the spatial relationships between pixel intensity values in grayscale image. By calculating the frequency of pixel intensity pairs at specific distance or offsets, GLCM provides valuable texture information for tasks such as image analysis and pattern recognition. HSP refers to hue, saturation, and value. It is a color space representation that separates an image into three components: hue, saturation, and value. This facilitates more intuitive color analysis, with hue representing the color itself, saturating indicating the color intensity, and value representing brightness, making HSV particularly useful for tasks involving color based image processing. Reading and resizing the image. Here, we read the image and resize the image to standardize for the format suitable for processing. Converting to color. Converting the color scheme of the images, possibly to grayscale and other format compatible with the chosen machine learning model. Appending images and labels. Combining the processed images with their corresponding labels indicating the presence and severity of wide-scale disease. Converting to NumPy array. Converting the processed images and labels into NumPy arrays for efficient handling and compatibility with the machine learning libraries. The next step is building the model. This step involves defining the parameters of the machine learning model and defining the architecture of the deep learning model, and that will be used for classification. Training the model. The model is trained using the pre-processed dataset. During training, the model learns to associate the extracted features with the corresponding labels, enabling it to make predictions on new unseen data. Flask framework with SQLite for sign up and sign in. Setting up a web application using Flask framework combined with SQLite database for user authentication. This allows users to sign up for an account and sign in into the system. User gives input. The application prompts the users to provide input, possibly in the form of uploading an image and entering the relevant information. The given input is pre-processed. The input provided by the user is pre-processed to align with the format expected by the trained machine learning model. This involves resizing, color conversion, and feature extraction. Model prediction. The pre-processed user input is passed through the trained machine learning model for prediction. The model evaluates the input features and produces an output indicating the likelihood and severity of wide-scale disease. Final outcome is displayed. The prediction result is displayed to the user, offering insights into the presence and degree of wide-scale disease in the date palm leaves. Now we will know what are the algorithms used in the project. The first algorithm is support vector machine, which is SVM. SVM is a supervised machine learning algorithm used for classification and regression tasks. It works by finding the hyperplane that best separates the data points into different classes while maximizing the margin between classes. SVM is effective for binary and multi-class classification tasks. Its ability to handle complex decision boundaries and high-dimensional feature spaces makes it suitable for image classification such as identifying different stages of the wide-scale disease in the date palm leaves. The next one is K-nearest neighbor. KNN is a simple instance-based learning algorithm used for classification and regression. It classifies new data points based on the majority class of their K-nearest neighbors in the feature space. KNN is particularly suitable for tasks where local relationships in the feature space are important. In the context of the project, it is effective for identifying similar patterns in the images and classifying the severity of the wide-scale disease based on the proximity of the neighbors in the feature space. Random forest is an ensemble learning method that constructs multiple decision trees during training and outputs the mode of the classes, which is classification, or the mean of the prediction, which is regression of the individual trees. Random forest is known for its robustness and ability to handle high dimensional data. It is suitable for image classification tasks, providing good accuracy and dealing well with the noisy or complex data, making it strong candidate for classifying the stages of wide-scale disease. Coming to LightGBM, it is a gradient boosting framework that uses tree-based learning algorithms. It is designed for distributed and efficient training of the large datasets, and it is particularly fast and memory efficient. LightGBM is chosen for its efficiency and speed, making it well suited for processing image data with a potentially large number of features. Its ability to handle large datasets and complex relationships in the data makes it an appropriate choice for classifying different categories of wide-scale disease in the date palm leaves. As an extension, we employed ensemble models, improving the accuracy and final prediction. Also, we have used Flash framework for user testing with the user authentication. We have used the performance metrics, which are accuracy, precision, recall, and FN score to evaluate this project. So here we have comparison graphs for all these metrics. This is accuracy comparison graph. Here on x-axis, we have accuracy score for each algorithm, and on y-axis, we have algorithm names. Similarly, we will have for other three metrics also. Accuracy is the measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is the precision score comparison graph. It is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall score comparison graph. Recall is also known as sensitivity or true positive rate. Recall measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is FN score comparison graph. FN score is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in the class distribution. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is DatePalm data, in which we have four different classes, and we use all these folders, which are the datasets for training the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file, which contains the algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of codes, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. So here, using the command cd, followed by the space, we need to paste the copied path. Path has not been copied, so we will copy it again. Here we will paste the path and then click on enter. By this, we can see that current directory is changed to the code folder's path. Here we need to type the command python space app.py and click on enter. This will compile app.py file and it will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. This is the localhost and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser. And this web page is built by using the Flask framework. Here you can see a sign up link. First, we need to click on that. And here we need to enter all the sign up details if you are signing up newly. I have already signed up and I have an account in it. So we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password to login. So I'm giving my username and the password. Now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a choose file button. We need to click on that to upload the date palm leaf images. These are the some of the date palm leaf images. We are going to use these images for the prediction. I'm choosing the first image to give as the input. So I'm selecting the first image. Click on open and now click on upload. Here we got the prediction for this leaf as The leaf is healthy, which means it has no wide scale disease. Now we will try giving the other image. Click on try again. Click on choose file. This time I'm selecting the third image. Now click on open and click on upload. So here for the given input image, we got the prediction as wide scale disease stage 1, which means the leaf is suffering from wide scale disease and it is at stage 1. Now we will give the other image and see what will be predicted. Click on try again. Click on choose file. I'm choosing this image. Click on open and click on upload. Here for the given date palm leaf image, we got the prediction as wide scale disease stage 2, which means the leaf is suffering from wide scale disease and it is at stage 2. Now we will give the other input image. Click on try again. Click on choose file. I'm choosing the last image. Click on open and now click on upload. Here for the given input image, we got the prediction as wide scale disease stage 3, which means the leaf is suffering from the wide scale disease and it is at stage 3. Now click on sign out. Similarly, if we upload the date palm leaf images to the system will predict whether leaf is suffering from wide scale disease or not. If it is suffering from, it will classify at which stage it is, whether it is 1, 2 or 3. Conclusion of the project is the project successfully demonstrates the effectiveness of machine learning techniques, specifically support vector machine, k-nearest neighbor, random forest, and light GBM in accurately identifying and classifying stages of wide-scale disease in date palm trees. Through the utilization of feature extraction techniques including gray level co-occurrence matrix, which is GLCM, and hue, saturation, and value, which is HSV, the project gains valuable insights into the characteristics of date palm leaf images, enhancing the precision of disease classification. The incorporation of ensemble learning methods, specifically voting classifier and decision trees, significantly contributes to the improved accuracy in disease classification. This underscores the effectiveness of combining diverse models for more robust and reliable predictions, enhancing the overall performance of the project. The proposed framework integrating image processing, machine learning, and Flask-based user interface with SQLite for user authentication offers a practical tool for the Oasis agricultural community. It enables early detection of wide-scale disease, aiding farmers in adopting timely preventive measures and protecting both date palm trees and crop yield. By providing a reliable and efficient solution for disease detection and classification, the project contributes significantly to the precision farming practices. This empowers farmers with means to make informed decisions, ultimately minimizing yield losses and preserving the overall health and productivity of date palm crops.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.